Okay, question 4, here we go. I will, when we do component 3, I will speak to you about Rhesus disease as such, and as a Rhesus negative mother, I did get anti-Ds injections during pregnancy and after deliveries. But I'll speak to you then about this entire thing. So it gives you a scenario of Rhesus D is a glycoprotein embedded in the cell membrane, gives you a lovely picture about that glycoprotein and points to various bits. I'll get back up to that diagram when we come to those points in the question. The actual question, scenario given. We've got the scenario. The question itself, state the level of protein structure present in an alpha helix. Okay, it doesn't tell you beta pleated sheet there, but you should have clicked, and that's the second type of that you're going to get in an alpha helix, and describe how its structure is maintained. So alpha helix, beta pleated sheet, you should click in, that was your secondary structure. And your maintenance of that structure, it doesn't specifically say state the bond types, but it means that. It's describing that, so that you've got your hydrogen bonds as part of the bond types here. Yeah, secondary structure, hydrogen bonds. Peptide bonds, they were as part of the primary structure where you've got the amino acids being linked together. That is core concepts, and you will get core concepts coming up over and over again. Second question here, state whether the region of the protein labeled H contains amino acids which are hydrophilic or hydrophobic. So the first point of your 2 marks here, is it hydrophilic or hydrophobic? And then why? Look at the diagram, H. Look at the labels, extracellular, the actual cell membrane, intracellular. So you've got a water-based medium interrupted by your phospholipid bilayer, and then again your water-based medium. H is automatically arranging itself in a way that it's not stuck in the cell membrane. It doesn't seem to want to be in the membrane. It wants to be in the water-based region. So hydrophilic, because it's orientated itself to be outside the cell membrane and in the water-based medium. So it wants to contact with water. Polar molecules, therefore, they're repelled by the hydrophobic fatty acids tails as the explanation of that whole thing. What was the follow-on question? So it is now telling the presence or absence of Rhesus D is controlled by a gene with 2 alleles. You've either got it or you don't. You're Rhesus positive or you're negative. And if a woman has Rhesus negative, which is me, if she becomes pregnant with a child who carries the dominant allele, I've got 2 dominant children, the mother will develop an immune response. Again, I'll give you the detail on that when we actually get to that in component 3. This is a component 3 scenario, but the actual question to go with it does link over into component 2, and it is one of those where you get the overlap. So apologies, I've been a bit nicer when marking for that reason. So prenatal testing of the fetus is determined by the blood group, which is carried out by analysing mother's blood, because you get some of the baby's blood in mother's blood. And this question here is actually then going back into what was your understanding of the reproduction unit. Why do we do a blood test on mom's blood rather than getting fetus samples or tissue samples, some sampling from the actual embryo? Why do we do mom's blood? Wouldn't it be better if you want to test the embryo to actually, sorry, to test the fetus, if we actually test the fetus itself? The key idea here is, how do you do least damage? How do you risk the least infection? How do you avoid possibly an abortion or an accidental damage to that fetus? So far less invasive to do a blood test on mom. And you do have mom's blood, baby's blood cells, you do have a fetal DNA in mom's blood. So non-invasive, doesn't involve taking tissue from the actual amnion placenta, and therefore no risk of infection, no risk of miscarriage, no risk of an accidental self-abort sort of thing, or harm to the fetus in whichever version. Obviously, if you argue it the other way around, that's absolutely fine too. What is our next one? Here we go. Hardy-Weinberg, don't we love it? Hardy-Weinberg, here we go. We've got our numbers. Determine the proportion. What are we getting? What is the information we are getting? We are getting the Rhesus negative, the 0.16. So that is our Q square. Okay, that is our Q square. From there, sorry, Q square. Okay, that is our 0.16. That is what we know as the ones are being rhesus negative. Going through the equation and thinking through, hold on a second, all those together have to be whatever is 1 minus 0.16. And your Q together plus your P together would give you 1. So your Q square, take the square root of it to get to your Q. 1 minus whatever that was gives you your P, filling in the whole equation to get to what is it that you actually need. Hold on a second. What does it actually ask you? Determine the proportion of the population in Europe who are homozygous dominant. So it doesn't ask you about how many of them are happy to have one allele for rhesus positive. It asks you which ones have got 2 alleles for homozygous dominant. And you should have, if you want to, you can pause all these videos as you go along. So you've got your P squared, here we go, square root of it, 1 minus to get to your, sorry, Q squared, square root that 1 minus your Q gives you your P, and then thinking, hold on a second, homozygous dominant, that's your P squared. Your homozygous dominant are these ones. They were your P squared. Okay, right, I'll leave that to you. If you've got issues with all those math things, just give me a shout. I'll come over, okay? Give me a shout and I'll be with you. And then this one is a little bit more awkward because you now have to think proportion of the population who are heterozygous. So here we go, heterozygous, that's that lot. That's your heterozygous lot. You should have your numbers in place already. Heterozygous lots of 2PQ, you could PQ, there we go, you've got your 0.48. It's nice here, it gives it to you as a percentage. However, the next one is not nice. The next question is not nice because if you look at the next question, here we go, heterozygous, here we go. This question here, state the percentage. So it doesn't want a proportion here, now it wants percentage of men in Europe who could not produce a rhesus positive child. The percentage of men in Europe which could not produce a positive rhesus child. Okay, if they cannot produce a positive rhesus child, means that they don't have an allele for positive. They only have the negative alleles. So which ones are we looking at? These ones. Okay, and then it's asking you to do the percentage of it. You've had your 1.6 in the, sorry, 0.16, you've had that in the question already. Where was it earlier in the question? You've had that one already. You knew that these ones are in the question, so that's your proportion, but now it wants it as percentage. So they ask for percentage, please give them percentage. Right, and that was it for question 4. No, we've got one more to go, and then that's it. Okay, Hardy-Weinberg, that was the one that came with the principle that it only works if your population is not in any version of flux. So no immigration, emigration, large population, nothing selecting against the phenotype. And it even gives you the idea here. And then it's asking you, from your understanding of what Europe is, this is asking you to think as a whole person here. From your understanding what Europe is, have we got a large population in Europe? So yeah, we do. Therefore, we should have a constance in Europe. However, do we have a selection against a phenotype? Yeah, rhesus disease. It described it earlier to you that we've actually got a kill the fetus situation. Okay, so that would be that you can't word it much stronger as selection against the phenotype. Is the population of Europe isolated? We do get immigration and immigration. Yep, so that criteria is not fulfilled. So here we go. The mark scheme is saying clearly, here we go, selection against a phenotype is, yeah, is there. So positive children are selected for, negative ones against, and population is definitely not isolated. We do have relatively free movement, or not relatively free movement. I'll leave that for you and your political brains to analyze.